Hello students, I hope that you are good, well and fine. In today's session, we will be seeing NCERT exercise 10.4 solutions based on cross product. Okay, so the first question of this exercise says that you have to find magnitude of cross product of A and B vectors. A vector is given and B vector is also given to you. So in order to find magnitude of A cross B, you will have to first of all find A cross B. And A cross B, you know very well how to find it. You have to find or evaluate a determinant. And what type of determinant? The first row will be I hat, j hat, k hat. Second row will be the scalar components of A vector, that is 1, minus 7 and 7. Third row will be the scalar components of vector B, means 3, minus 2 and 2. Let's see. As you can see, we have done the same thing as I have already told you. Now the determinant will be I hat times 2 multiply minus 7 minus 14. Minus of minus 14 gives you plus 40. Okay. Now minus j hat times 2 minus 21 plus k hat times minus 2 plus 20. So this will be this will be vanished, as you can see, minus 14 and plus 40. This will be 19j and this will be also 19 but k, 19k hat. So you will have your A cross B vector as 19j hat plus 19k hat. Okay, now in order to find the magnitude, what you have to do, first of all do the square, sum the squares of the scalar components and then add. Okay, and then apply the root. As you can see here, what we are doing, the squaring the scalar components and then adding them and then applying square root, sorry, not a square, applying square root, you will get your magnitude. Okay, so 19 root 2 will be your magnitude for the given A cross B cross product. Okay, now second question, find a unit vector perpendicular to each of the vectors A plus B and A minus B, where A vector is given and also B vector is given. So in order to find, first of all, we have to find the unit vector perpendicular. So whenever you are asked to find a perpendicular vector to the given vectors, the first thing comes to your mind is cross product, because the resultant of the cross product gives you the another vector which is perpendicular to the vectors which we had just did the cross product. Okay, now so this means you have to do cross product between this vector and this vector. So first of all, find this vector A plus B and then find this vector A minus B and then apply the cross product in between them. So A plus B, you will get A plus B by just adding the corresponding scalars. So you will get 4i hat, 4j hat and 0k hat. This means just 4i hat plus 4j hat. What A minus B means 2i hat, 0j hat, okay, and plus 4k hat. So this means 2i hat plus 4k hat will be your A minus B. Now cross product. So cross product between these two vectors, you will have these. You will have the determinant. Now solving the determinant, you will get 16i hat minus 16j hat minus 8k hat. So this will be your, now this vector will be your perpendicular vector to A plus B and as well as A minus B. But you have to find the unit vector. Okay, so make it a unit. How? Just divide this vector by its magnitude. So the magnitude for this vector will be what? Root of sum of squares of the scalar components. So as you can see, root of sum of the squares of scalar components. As you can see, you will get 24 as your magnitude. So you will get 24 as your magnitude. So the unit vector will be this. Okay, I hope it is clear to you. Let us move next. Now, third problem. If a unit vector A makes angles pi by 3 with I hat, pi by 4 with j hat, and an acute angle theta with k hat. Okay, then find theta and hence the components of A vector. Okay, so when it is given that if A unit vector, so A is what? Your unit vector. Okay, this means the magnitude for A will be 1. Okay, as you can see here, we are in general taking A vector might be looking like this. It must be having some scalar components as A1, A2, A3. Okay, then your component form will be like this: A1 I hat plus A2 J hat plus A3 K hat. You have to just find A1, A2, A3. Okay, now this vector, okay, this vector, as you know, that with I hat it is making pi by 3. This means cos pi by 3 must be A1 divided by magnitude of A. This means cos pi by 3 means what? 1 by 2 is equals to A1. So A1 is 1 by 2. With j hat it is making pi by 4. So this means cos pi by 4 is equals to A2 divided by magnitude of A. This means A2 will be 1 by root. Now with k hat it is making theta. This means cos theta will be A3. Cos theta will be A3. Okay. Now you know that the magnitude must be 1. Okay. So apply the things. You will have this. Okay. After squaring both sides, you will get 1 by 4 plus 1 by 2 plus cos square theta is equals to 1. Solve it. You will have cos theta is equals to half. This means theta must be pi by 3. So your A3 will be 1 by 2. This means your components will be 1 by 2, 1 by root 2 and 1 by 2. Clear? As you can see. Okay, easy. I hope that you find it very easy. The only thing you have to crack was this, that you have given that with I hat it is making pi by 3 angle, your vector A. With j hat it is making pi by 4 and with k hat it is making angle theta. And you already seen such concept. Okay. Now let us move next. Question number 4. Show that the cross product between A minus B and A plus B vectors must be 2 times of A cross B. Okay, let's see. So first of all, we will be using distributive property of vectors over addition. So it will be what? This whole going to be cross product with A and then add, and now going to be with B, as you can see. Now again distribute. You will have A cross A minus B cross A plus A cross B minus B cross B. You all know that minus B cross A is same as minus of minus A cross B. This means plus A cross B. Okay, clear? A cross A, whenever a vector cross product with itself, the result will always be 0. Okay, the result will always be 0. So 0, 0 vector. 0 means 0 vector. So you will have just what? 2 times A cross B. You will have this thing 2 times A cross B. Okay, I hope it is clear. There must be there must be a bracket. Okay, this form must be there. Okay, so do not confuse. It is just like this, 2 times A cross B. Clear? I hope it is clear to you. Now, fifth problem. Find lambda and mu if the cross product of two vectors is given to you equal to 0 vector. Given to you 0 vector. So after finding the cross product, you have to compare your components, scalar components, corresponding scalar components. Okay, then you will get your lambda as well as your mu value. Let's see. First of all, find the cross product. Okay, so you will have this as your determinant, and this right hand side must be, as it is 0 vector, this means in component form it will be looking like this. Now find the determinant. You will have I hat times this minus j hat times this plus k hat times this. Now comparing, this means I hat component, I hat, this corresponding component must be say equal to 0. This means 6 mu minus 27 lambda must be 0. Now j hat component must be same as this minus of this. So you will have 2 mu minus 27 is equals to 0. And 2 lambda minus 6 must be same as 0. So now solve them. So here from last equation, you can get that lambda must be 3. Yes, lambda must be 3. If lambda is from here, lambda is 3. What about mu? Mu will be 27 by 2. Yes, this means 13.5. Okay, so mu value will be 27 by 2 and lambda value will be just 3. I hope it is clear. So your lambda and mu values are these 3 and 27 by 2 respectively. Very easy to find. Just find the cross product and do your compare your things to find the corresponding component. Now sixth problem. Given that A dot B is 0. Given that A dot B is 0 and A cross B, okay, is also 0 vector. Here it is scalar 0. As you know that it is a scalar product, and here it is 0 vector because cross product gives you the vector. So what can you conclude about the vector A and B? So from here, what you can conclude is perpendicularity. Yes, what can you conclude is perpendicularity, or another way is that you can also conclude that either magnitude of A is 0 or B is 0. Then this can be happening. Okay, and this case will only occur when A is 0 vector or B is 0 vector. Okay, now what is happening? Observe something. What? Okay, so either if you know that A dot product B is 0, this means two things will be happening. Either A or B are 0 vectors, yes, or they must be perpendicular to each other. Okay, now then this will happen. Now second thing will be happening that either the A or B vectors are 0. Okay. Or A and B are parallel. Why? Because in parallel cross product must be 0. Okay. So parallel thing. This means, but as you know that A and B cannot be perpendicular and parallel at the same time. This cannot happen. Yes. From here, if it is perpendicular, then you cannot say that they are parallel to each other. If you are saying that it is parallel to each other, you cannot say they are perpendicular. Okay. Cannot occur simultaneously. So the only possibility we have left is that either A is 0 or B is 0. So the conclusion will be your either of the given vectors must be 0. Okay, clear? I hope it is clear to you. Okay. Now, why I am saying they are 0? As you know, the magnitude must be 0 when, in what case you will have your magnitude is equals to 0. In what case you have your magnitude is equals to 0? Only when the components of a vectors are all 0. Okay. Now, seventh problem. Let the vectors a, b, c be given as a1 I hat plus a2 j hat plus a3 k hat, b1 I hat plus b2 j hat plus b3 k hat, c1 I hat plus c2 j hat plus c3 k hat. Then show that it is true. What? That a cross product with b plus c is same as a cross product with b plus a cross product with c. Okay. Let's just show. So a, b, c are respectively given. First of all, b plus c will be b1 plus c1 I hat plus b2 plus c2 will be times j hat plus b3 c3 k hat. Now, a cross product with b plus c vector, you will have I hat, j hat, k hat, a1, a2, a3, b1 plus c1, b2 plus c2, b3 plus c3, this determinant. Then solve this determinant, you will get this whole big expression. Now, the right hand side, a cross b, let's find a cross b. A cross b will be that this determinant I hat, j hat, k hat, a1, a2, a3, b1, b2, b3. Clear? Now, after evaluating this determinant, you will have this as your expression. Okay. Now, a cross c, I hat, j hat, k hat, a1, a2, a3, c1, c2, c3. After evaluating this determinant, you will have this as your expression. Now add them, a cross b and a cross c. You will have what? This as your expression. Now try to see that the scalar components for this vectors and scalar components from this vectors. What are the similarities and what are the differences? Let's try to see. So first scalar a2 b3 a2 c3, as you can see, a2 b3 a2 c3 minus a3 b2 a3 c2. So minus a3 b2 minus a3 c2. So the first corresponding component, scalar component, is same. What about second? You can check the other one also, that they are also same. So this means you have that a cross product with b plus c same as a cross product with b plus a cross product with c. So we have proved the result. So this means you can distribute your a in cross product over addition, as you can see. Yes, I hope it is clear to you. Now let us move next. Eighth problem. If either a or b is 0, if either a or b is 0, then cross product is 0. Okay. Is the converse true? Justify your example. Justify your answer with example, obviously. So take any two parallel vectors. Take any two parallel vectors like this. A is this, B is this. Why I am saying they are parallel? Because B can be written like 2 times of A. Okay, so that's why they are parallel. Find the cross product. The cross product you will get is 0 vector. Cross product you will get is 0 vector. This means, but here you can see the magnitude for A. The magnitude for A, okay, as you can see that A is non-zero and B is non-zero. Both are non-zero vectors. But still the cross product is going to be 0. So converse is not true. Clear? I hope it is clear to you. Let us move next. Find the area of the triangle with vertices A, B, C given. So very easy. How you are going to find the area? We have already given area that half times the cross product of two such vectors where they must have co-initial points. Okay, the both vectors must be co-initial. Okay, and the sides of the given triangle. So let's see what we are taking. So as you can see, the vertices of triangle. Now adjacent sides AB, BC. Okay, AB and BC, they are given. AB vector will be this, BC vector will be this. Now area of triangle ABC is equals to half of what? AB cross product with BC. You will have what? Determinant. Then evaluate your determinant. What will be your answer? The determinant output will be minus 6i hat minus 3j hat plus 4k hat. Okay, and this will give you your AB cross BC vector, and the magnitude for it will be root 61. The magnitude will be root 61 and the area will be root 61 divided by 2 square units. So the area will be, the required area will be this. Okay, clear? I hope it is clear to you. Okay. now what is happening is that okay, I hope it is clear to you. Okay, let us move next. Now 10th problem. Find the area of the parallelogram whose adjacent sides are determined by the vectors A and B. So very simple. The area will be the cross product thing. Okay, the area will be the modulus of or the magnitude of cross product. Okay, now so magnitude of cross product of AB. So cross product of AB will be 20i hat plus 5j hat minus 5k hat. Now magnitude will be root of 20 square plus 5 square plus 5 square. This means root of what? 400 plus 25 plus 25. In other words, 15 times root 2 will be your answer. Clear? I hope it is clear to you. As the information already given to you that the adjacent sides are determined by the vectors A vector and B vector. Okay. Now 11th problem. Let the vectors, two vectors A and B, be such that the magnitude for A is equals to 3 and B for B is equals to root 2 by 3. The cross product is a unit vector. This means the resultant or the output for the A cross B will be our unit vector. This means magnitude must be 1. If the angle between A and, you have to find the angle between A and B. So you know the formula. What formula? That A cross B is equals to magnitude of A multiply with magnitude of B multiply sine theta n cap, where n cap is your unit vector perpendicular to both A and B. Clear? Perpendicular to what? Both A and B. Now, you know the magnitude for A cross B is equals to 1. Now apply the magnitude or modulus thing both sides. You will have what? Modulus of magnitude of A multiply magnitude of B multiply sine theta n cap is equals to 1. Now this is what your, as n cap is a unit vector, this means magnitude for it will be also 1. So you can simplify in this form. This is 3, this is root 2 by 3, this means 3 can be cancelled. From here you can get sine theta is equals to 1 by root. And for what value of theta? Sine theta is 1 by root 2, you all know, 45 degree. This means in radian pi by 4 radians. So theta must be pi by 4. So angle between A and B must be pi by 4. So option B will be your correct option. Now the last problem of this exercise, 10.4. The area of a rectangle having vertices A, B, C, D with position vectors, you are given the position vector, okay, respectively. So you have to find out the area. So very easy. You have to first of all find the adjacent sides. So in order to get those, you will have to find adjacent sides. We will be taking AB and BC. Okay. AB will be, as you can see, 2I hat, just AB. Okay, AB will be just 2I hat, as 1 plus 1, half minus half, 4 minus 4. This means 2I hat. And BC will be 1 minus 1. Okay, minus half, and 4 minus 4. This means minus J hat. Now cross product, you will have minus 2K hat. Now magnitude for it will be just 2. Now what about the area? Just simple. Area is just nothing. Okay, from what? The parallelogram. The area of a parallelogram whose adjacent sides A and vector, whose adjacent sides are A and B, the area will be the magnitude of A cross B. This means your area will be what? The cross product, magnitude of cross product of AB and AC. This means 2 square units. So the answer C will be your correct answer. Okay, so this is it for now. I hope that you understood. You saw how we are approaching to solve our questions. What are the essential things you must know in order to find the cross product? Okay, so you must know the basic formula. You must know the perpendicularity condition. You must know the parallel conditions. Okay, clear? You must know about unit vectors. You must know about area formulas for rectangles, for parallelogram, for triangles. Okay, you must know about their conditions also. What are the basic conditions? Okay, so this is it for now. So we will be back with the miscellaneous problem, the only thing remaining in this chapter. Clear? So thank you all. We will be back with some more problems so that you can have better idea of what is vector algebra and what are the things we have learned so far. So again, thank you.